Okay, so we have to find the third derivative of the velocity vector given to us, and then we have to find the position vector RT. So first we find the first derivative of the velocity vector. So we have 2t, derivative of sine t is cosine t, minus, we have product rule, so the derivative of the first times the second, which is just cosine of t, plus the derivative of the second, so the derivative of cosine is negative sine of t, times the first, which is t, and then we have the derivative of cosine, which is negative sine of t, plus, again, product rule, so the derivative of t is 1 times sine t, which is just sine of t, plus the derivative of sine is cosine of t times t, which gives us 2t. Cosine t minus cosine of t cancel out. So, and then we have negative and negative, which becomes positive. So we have t sine t, and then we have negative sine t plus sine t cancels out, and we are left with just t cosine of t. So then we find our second derivative, which we have 2. Again, the product rule, so the derivative of t is 1 times sine t, so we have sine t, plus the derivative of sine, which is cosine of t times t, and then we have the derivative of t, which is 1 times cosine, which is just cosine of t, plus the derivative of cosine t, which is negative sine of t times t, which gives us 2 sine t plus t cosine of t, and then we have cosine of t minus t sine of t. So then we can find our third derivative, which is the derivative of 2 is 0. The derivative of sine is cosine. Plus product rule, which is cosine of t, plus the derivative of cosine is negative sine, so minus sine t times t, and then we have the derivative of cosine, which is sine t, minus negative sine t minus sine t plus the derivative of sine, which is cosine of t times t, which gives us 0 to cosine t minus t sine t, and then we have negative 2 sine t plus, minus t cosine t, which gives us our third derivative. And then to find the position vector rt, we have to integrate our velocity vector with respect to t. So we have r of t equals the integral of t squared dt and then we have the integral of sine of t minus t cosine of t dt plus the integral of cosine of t plus t sine of t dt. So we have t cubed over 3 plus c1. Then we have the integral of sine t is cosine of t and then we use, so to find the integral of t cosine of t, we have to do integration by parts. So we set u equal t, dv equals cosine of t, and we can do du is 1 dt, and v equals sine of t. So then integration by parts is, using integration by parts, we get minus t sine t minus the integral of sine t dt, and then we get the integral of cosine of t is sine of t. And then again, using integration by parts, we get we get this, which gives us minus t cosine of t minus the integral of negative cosine t dt. So then we get t cubed over 3 plus c1 we get the vector negative 2 cosine of t minus t sine t plus c2, and then we get 2 sine of t minus t cosine of t plus c3. Then plugging in t equals 0 to our position vector, we can find our C1, C2, and C3. So plugging in 0, and then we get negative 2 cosine of 0 minus t, minus 0 sine of 0 plus c2, and then 2 sine of 0 minus 0 cosine of 0 plus c3. So we get c1 equals 0, c2 equals 2, and c3 equals 0. So finally our position vector is t cubed over 3 negative 2 cosine t minus t sine t plus 2, and then we get 2 sine of t minus t cosine of t, and that solves for the position vector.